Now, just a second ago, I was going over those fact families and I talked about that commutative property. What the commutative property says is I can change the order of something and it will give me the same answer. For instance, 3 plus 5 is equal to 5 plus 3. Commute means like we're moving around. So like if you are a commuter on campus, you have to drive into campus, you're moving around. So we're moving the order around and we still get the same answer. That is true for whole number addition. Associative deals with who we associate with. So right now my expression here, 3 plus 2 are associating together. I'm going to keep them in the same order. Notice it's still 3, 2, 6, 3, 2, 6. But now I'm going to make 2 associate with 6. So I'm changing what's inside the parentheses. Do not think that just every time you have parentheses, it is associative. For instance, I'm going to come up here to this commutative. And I'm going to keep my same first example. I could just change the order, but what was in the parentheses stayed the same. That would be commutative. So if you see parentheses, don't just assume it is associative. Really think about it. Commutative means I changed the order. So I just read across 3, 2, 6, 6, 3, 2. Nope, not the same order. So that's the commutative. You can combine these together. We're not going to have any problems like that. We just want to learn the basic definition of commutative and associative. Now, identity, if we think about our identity, that's who we are. So for identity, we want to keep our identity the same. So if I took 2, there's only one number in the world I can add to it to get 2, and that's 0. So the additive identity is 0. It's important to remember that we're talking about adding now because we're going to get to multiplicative identity later on. But the additive identity for any number is 0. I'll write that up. That's usually how we write up, with a there meaning for any number whatsoever. It's a variable. And it doesn't matter what comes first, the 0 or the number, the other number. We're still, oops, I think I wrote a 0. I didn't finish it. It's equal to a. Oh, glad I caught that. Put a 0 there instead of an a. So we could all think of a different number. We could say 0 plus 27 is going to get me back to 27. Now, there's one property that you might not have heard of before, and that's closure. So I'm going to actually write up some words with this and give some examples. So if A and B, these are going to be two numbers, are in a set, then the sum A plus B must also be in the set. So if something is closed, basically the answer, the sum, must also be in a set. So let me give you an example. This set 2, 4, 6, 8. It's got a dot, dot, dot on the end. So we've seen that before. That means it goes on and on forever. That ellipse means that it goes on forever. So this is just all the even numbers. Let's see. Let it finish saving. So if I were to take 2 plus 4, 6 is in the set. I also could take maybe 4 plus 8. That's 12. I don't see it, but I see this ellipse, so I know 12 is also in the set. So if you add any two even numbers together, their sum is in the set. So we say this is closed. Yes, it is closed. Let me give you another set to think about. This time, I'm going to make it not have the ellipse on the end. So this is just a set with 4 elements in it. 2, 4, 6, and 8. So again, I'm going to check it. 2 plus 4 is 6. That's in the set. But 10's not in the set. 4 plus 6 isn't in there. So if you just have one answer that's missing, doesn't matter how many good answers are in there, but if one answer is missing, we say it is not closed. It did not have the answer in it. All right, I want to give you 2 to think about. So I'm going to give you these guys to think about. The second one's kind of a little tricky one, but I want you to think about it. And I'm purposely giving it to you. It comes up on my math lab, and a lot of times people get confused by it. So I want to go ahead and go over it. So go ahead and hit pause and see if you can figure out if these are closed or not. Let's look at this first one. These are the odd numbers. If you didn't try it, go ahead and hit pause now and try it. These are the odd numbers. So if I were to take any two of these numbers, if I add them together, the answer is not in the set. An odd number plus an odd number will always give me an even number. 3 plus 5 is 8. 3 plus 7 is 10. 5 plus 7 is 12. 11 plus 9 is 20. Two odd numbers added together, the sum is even. So we say this guy is not closed. All right, let's look at this one down here. If I were to take these numbers and add them together, I would get 1, and the sum's in there. But technically, remember, in a set, we don't show repeats. We never want to show that repeat, but there could be a repeat. So 0 plus 0 is in the set. But 1 plus 1 is not in the set. So this guy is also not closed. I could do that for all these guys up here. I could come back to the top and I could have 4 plus 4 is 8. Yep, that's in the set. Here, 3 plus 3 is 6. It's not in the set. So we can have that idea that we could reuse numbers in a set. We just don't write them more than once because in sets, the grammar is you don't show the repeats.